Introduction. Chemistry deals with the composition, structure, and properties of matter. These aspects can be best described and understood in terms of basic constituents of matter, atoms, and molecules. For example, medicines, vitamins, tonic, fertilizers, industry, polymers, soaps, detergents, waterproof clothes, and fireproof building material all are related to chemistry. Objectives. At the end of this lesson, you'll be able to understand and appreciate the role of chemistry in different spheres of life. Explain the characteristics of three states of matter. Classify different substances into elements, compounds, and mixtures. Define SI base units. Differentiate between precision and accuracy. Importance of chemistry. Chemistry plays an important role in meeting human needs for food, healthcare products, and other materials aimed at improving the quality of life. This is exemplified by the large-scale production of a variety of fertilizers, improved varieties of pesticides and insecticides. Similarly, many life-saving drugs, such as cisplatin and Taxol, are effective in cancer therapy, and AZT, zidothiamidine, used for helping AIDS victims, have been isolated from plant and animal sources or prepared by synthetic methods. Nature of matter. Matter is any material substance with mass and volume. Everything around us, for example, book, pen, pencil, water, air, all living beings, etc., are composed of matter. Physical states of matter. Matter can exist in three physical states like solid, liquid, and gas. Solids have definite volume and definite shape. Liquids have definite volume but not the definite shape. They take the shape of the container in which they are placed. Gases have neither definite volume nor definite shape. They completely occupy the container in which they are placed. Classification of matter. At the macroscopic or bulk level, matter can be classified as mixtures or pure substances. Mixtures. Many of the substances present around us are mixtures. For example, sugar solution in water, air, tea, etc. are all mixtures. A mixture contains two or more substances present in it in any ratio which are called its components. For example, coffee contains a complex mixture of chemical compounds. Types of mixtures. A mixture may be classified into homogeneous and heterogeneous. Homogeneous mixture. In a homogeneous mixture, the components completely mix with each other and its composition is uniform throughout. Example, mixture of sugar in water, mixture of salt in water, mixture of copper sulfate in water. Heterogeneous mixture. In heterogeneous mixtures, the composition is not uniform throughout and sometimes the different components can be observed. Example, the mixtures of salt and sugar, grains and pulses along with some dirt, often stone pieces. Pure substance. Pure substances have characteristics different from the mixtures. They have fixed composition, whereas mixtures may contain the components in any ratio and their composition is variable. Example, copper, silver, gold, water, glucose. Classification of pure substance. Pure substances can be further classified into elements and compounds. An element consists of only one type of particles. These particles may be atoms or molecules. Example, hydrogen, helium, carbon, sodium, copper, silver, oxygen, etc. Compound. When two or more atoms of different elements combine, the molecule of a compound is obtained. The examples of some compounds are water, ammonia, carbon dioxide, sugar, etc. Properties of matter. Every substance has unique or characteristic properties. These properties can be classified into two categories: physical properties and chemical properties. Physical properties are those properties which can be measured or observed without changing the identity or the composition of the substance. Examples: color, odor, melting point, boiling point, density, etc. The measurement or observation of chemical properties require a chemical change to occur. Examples: characteristic reactions of different substances. These include acidity or basicity, combustibility, etc. The International System of Units, SI. The SI system has 7 base units, and these units pertain to the 7 fundamental scientific quantities. The other physical quantities such as speed, volume, density, etc. can be derived from these quantities. The definitions of the SI base units are given in table. The SI system allows the use of prefixes to indicate the multiples or sub-multiples of a unit. Mass and weight. Mass of a substance is the amount of matter present in it, while weight is the force exerted by gravity on an object. The mass of a substance is constant, whereas its weight may vary from one place to another due to change in gravity. The mass of a substance can be determined very accurately in the laboratory by using an analytical balance. Volume and density. Volume has the units of length raised to the power 3. So, in SI system, volume has units of meter cube. In chemistry laboratories, smaller volumes are used. Hence, volume is often denoted in centimeter cube or decimeter cube units. A common unit, liter, L, which is not an SI unit, is used for measurement of volume of liquids. 1 liter is equal to 1000 milliliter. 1000 centimeter cube is equal to 1 decimeter cube. In the laboratory, volume of liquids or solutions can be measured by graduated cylinder, burette, pipette, etc. A volumetric flask is used to prepare a known volume of a solution. Density of a substance is its amount of mass per unit volume. So SI units of density can be obtained as follows. SI unit of density is equal to SI unit of mass upon SI unit of volume, which is equal to kgm raised to the power minus 3 or gcm raised to the power minus 3. Temperature. There are 3 common scales to measure temperature: degree Celsius, degree Fahrenheit, and Kelvin. Here K is the SI unit. Generally, the thermometer with Celsius scale are calibrated from 0 degree Celsius to 100 degree, whereas these two temperatures are the freezing point and the boiling point of water respectively. The Fahrenheit scale is represented between 32 degrees to 212 degrees. The temperatures on 2 scales are related to each other by the following relationship. Degree Fahrenheit is equal to 9/5 degrees Celsius plus 3. The Kelvin scale is related to Celsius scale as follows. Kelvin is equal to degree Celsius plus 273.1. Significant figures. Significant figures are meaningful digits which are known with certainty. The uncertainty is indicated by writing the certain digits and the last uncertain digit. Rules for determining the number of significant figures. All non-zero digits are significant. Example, In 285 centimeter, there are 3 significant figures, and in 0.25 milliliter, there are 2 significant figures. Zeros preceding to first non-zero digit are not significant. Such zero indicates the position of decimal point. Thus, 0.03 has 1 significant figure and 0.0052 has 2 significant figures. Zeros between 2 non-zero digits are figures. Zeros at the end or right of a number are significant provided they are on the right side of the decimal point. Example: 0.200 gram has 3 significant figures. But if otherwise, the zeros are not significant. For example, 100 has only 1 significant figure. Exact numbers have an infinite number of significant figures. For example, in 2 balls or 20 eggs, there are infinite significant figures, as these are exact numbers and can be represented by writing infinite number of zeros after placing a decimal, that is, 2 is equal to 2.0000 or 20 is equal to 20.00000. 4.01 into 10 raised to the power 2 has 3 significant figures, and 8.256 into 10 raised to the power minus 3 has 4 significant figures. Addition, subtraction, multiplication and division of significant figures. Points for rounding of the numbers. 1. If the rightmost digit to be removed is more than 5, the preceding number is increased by 1. Example, 1.386. If we have to remove 6, we have to round it to 1.39. 2. If the rightmost digit to be removed is less than 5, the preceding number is not changed. Example, 4.334. If 4 is to be removed, then the result is rounded up to 4.33. 3. If the rightmost digit to be removed is 5, then the preceding number is not changed if it is an even number, but it is increased by 1 if it is an odd number. Example, if 6.35 is to be rounded by removing 5, we have to increase 3 to 4, giving 6.4 as the result. However, if 6.25 is to be rounded off, it is rounded off to 6.2. Did you know the phlogiston theory viewed phlogiston as a component of all matter? The burning of a material was considered to be the escaping of phlogiston from the matter. If a material did not burn, it was considered to contain no phlogiston. The phlogiston theory. In this theory, burning was considered to be the escape of phlogiston into the air. Smelting combined phlogiston-poor ore with phlogiston from a fire to make a metal. Metal rusting was considered to be the slow escape of phlogiston from a metal into the air. Summary. Let us summarize what we have learned. All substances contain matter which can exist in 3 states: solid, liquid, or gas. Matter can also be classified into elements, compounds, or mixtures. The measurements of quantities in chemistry are spread over a wide range of 10 to 31 to 10 plus 23. Hence, a convenient system of expressing the number in scientific notation is used. The uncertainty is taken care of by specifying the number of significant figures in which the observations are reported. The combination of different atoms